Okay, so number 29. While driving to work last year, I was holding my coffee mug in my left hand while changing the CD with my right hand. Then the cell phone rang, so I placed the mug on the flat part of my dashboard. Then, believe it or not, a deer ran out of the woods and on the road right in front of me. Fortunately, my reaction time was 0, and I was able to stop from a speed of 20 meters per second in a mere 50 meters, just barely avoiding the deer. Later tests revealed that the static and kinetic coefficients of friction of the coffee mug on the dash are 0.50 and 0.30 respectively. The coffee and mug had a mass of 0.50 kilograms, and the mass of the deer was 120 kilograms. Pretty big. Did my coffee mug slide? Now, first of all, I don't recommend that you try this question at home. It's very, very dangerous to not have your hands on the steering wheel while you're driving. So, let's just be happy that in this situation we are even alive. So, how do we start off this question? So, let's start off with just going off of what we know. So, we know the initial velocity of the car, which is also the initial velocity of the mug in reference to the road, because the mug is inside the car. And we know the distance it took for us to stop, and we also know all this information about the mug. Now, we were also given a mass for the deer. This doesn't matter because we're literally not even coming in contact with the deer, so we're just going to completely disregard it. So first of all, we need an acceleration. So we're just going to use our kinematics equation and plug in everything that we know. The final velocity is going to be 0 because we stop. And so the deceleration value is going to be equal to negative 4 meters per second squared, and it's negative because it's a deceleration value. Now, let's just look at a free body diagram of the mug real quick. So we have the normal force acting upwards and the gravity force acting downwards, and we also have static friction. Now, the reason I'm using static friction is because the mug isn't moving in accordance to the dashboard. It's only moving in accordance to the pavement, so the static friction isn't affecting the static friction is only acting in terms of the mug and the dashboard. So that's our free body diagram. Now, the magnitude of friction force needed for the mug not to slide is going to come from Newton's second law. So we know that the force is equal to mass times acceleration, and so we're just going to plug in the stuff that we know. And so we're going to get 2 newtons of friction, and this is the friction that's actually happening because of this acceleration. Now, the maximum static friction force, or what can happen, the maximum static friction force you can have, is going to be equal to the static friction coefficient times the normal force. And in this situation, since there's no vertical motion, the normal force is going to be equal to the force of gravity, which is equal to the mass times the acceleration due to gravity. And so we're just going to multiply all of these. So we have 0.5 times 0.5 kilograms times 9.8 meters per second squared. And we're going to get 2.45 newtons. Now, because the actual friction force is less than the maximum friction force, the mug doesn't slide. And this comes directly from our textbook, which states that if the actual friction force is less than the maximum static friction force, it will continue to stay at rest in regards to the surface it is on. And so our learning goals for this particular question is kinematics, linear motion, friction, and Newton's second law. And the reason I say friction is because in this situation, we really need to be able to figure out which type of friction to use. In this situation, because the mug was at rest in accordance to the surface it was on, we are using static friction, which is the friction opposing motion of an object at rest. And kinetic friction is the friction opposing motion for an object that is already in motion. So yeah, that's number 29. Thank you very much, and I hope you have a lovely day.